AP Stats. We're finishing up this packet, measures of variability. All right, so measures of variability. We've talked about range, obviously. That's your max minus your min. And then you've got three other measures of variability, which tell us how spread out the data is. We have variance and standard deviation, and those two have a relationship together. And then we have interquartile range. All right, so let's talk about these. So, out of these two, which do we think has more variability? Which data is more spread out? Number 1 or number 2? I hope you said number 2 was more spread out. You can see it's got a longer range, and there's more data pieces away from the mean in the middle. Here, it's a little bit closer together, right? So, all of these 4 things will tell us different things about how spread out the data is. All right, range, the difference between the largest and the smallest value of a data set. All right, so what's the range of the semester 1 tutorial group? So if you look in here, we need the greatest minus the least. We need the largest value minus the smallest value. So looking here, this is a histogram, right? So we can see the size of the tutorial group, the max number is 6, and the min number is 4. So my range is going to be 2. All right, I want you to go ahead and try and find the range of the semester 2 tutorial group. All right, I hope you did 7 minus 3, which would give me 4. So you can see that obviously number 2 is more spread out than number 1, just by using the range as a measure of spread, right? 4 is bigger than 2. This is spread out. All right. Standard deviation. So standard deviation is the overall measure of how spread out the individual data points are from their mean, from their average. So standard deviation compares all the other points to the mean in the data. Data sets with more spread from the mean have larger standard deviations, and data sets with less spread from the mean have smaller standard deviations. All right, remember earlier in the live session where we talked about mu and x bar, where mu is the true population mean, and we don't always know that. We're trying to estimate it. X bar is from the sample mean, right? So we have 2 different variables for standard deviation as well. We have S, which means the sample standard deviation, and then the entire population standard deviation is designated with the Greek letter sigma. So we have 2 different, this is for the sample, this is for the entire population. All right, so looking at this, which has the largest standard deviation? Which has the smallest? So remember, we're trying to think about how far away the data points are from the mean, right? So looking at this, it looks like my mean is going to be right about here. Here, it looks like my mean is going to be here. And here, my mean is here. And would this be mu, or would this be x bar? The mean that I drew within these data sets, right? Would this be the true population mean, or would it be the mean of the sample? I hope you said x bar, because I'm estimating the mean from the sample. This sample only includes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It only includes 10 dots. It's not the entire population, right? So this is the mean of those 10 dots, so I would call that x bar. All right, looking at these, I'm going to label them A, B, and C. I want you guys to tell me which one has the largest standard deviation. Which one is the most spread out of all 3? All right, I hope you said A, largest standard deviation. That's because you can see it's got data points as far away as 0 and 6 when that mean is at 3, right? Everything else is closer together. All right, so now looking at this is kind of tricky because they look pretty symmetric. So which one do you think has the smallest standard deviation of all 3? I can eliminate A because A is the largest. So which one has a smaller standard deviation between B and C? What has less points further away from the mean? All right, I hope you said C. C has the smaller standard deviation because you can see the furthest out from the mean I only have 2 data points, and close to the mean, I have 3 data points on either side. If you're looking at B, it looks like I have 3 data points away from the mean, furthest away from the mean, and 2 on the inside, right? So I have more data points away from the mean, which is going to give me a larger standard deviation than here. So see, I only have 2 on the very outside. I have 3 on the very outside here, which would give me a larger standard deviation. All right. Interquartile range. All right, the middle 50% of the data set. So the interquartile range is going to be your Q3 minus your Q1. So looking at this, I've got a data set right here, and the numbers are ordered from 62 to 81. First, let's see what the sample size of this data set is. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 10 numbers, and I've ordered them in a row, right? So they're going from smallest to largest. So I can figure out the max, 81 minus 62. My median is the middle number, and it's right in between these 2 middle numbers because I have an even data set, right? So my median is going to be 71. Your interquartile range is going to be the middle number of the lower half and the middle number of the upper half. So see, we drew this line right in the middle of the data, right? So I've got my lower half, and I see that 64 is right in the middle of the lower half, and 77 is right in the middle of the upper half. So my interquartile range is going to be my Q3, 77, minus 64, my Q1. All right, when a data set contains outliers, which measure of variability is more useful? So range or IQR? So think about it. If a data set has outliers, that means your max or your min is going to be really big. So if I take the range, then it makes it seem as if my data is very spread out, whereas one outlier could be causing that really big range. So your IQR is actually more useful when your data has outliers, because you can get an idea of where the middle 50% of the data is. So same how median is more useful than mean when data sets contain outliers, IQR is more useful than range. All right, I assume that none of you have the TI-84s because I have them here in my classroom. So I'm going to show you how to put the data set into the Desmos app to figure out the IQRs. All right. All right, we'll do this data set of 6. All right, I'm going to go to my Desmos app. I'm going to hit, all right, let me try and get this in. I'm going to hit the function key right here, and then I'm going to hit stats, and you'll see to find the standard deviation of the set, I'm going to hit stdev. And then all I need to do is put my data set in. And I get my standard deviation of 2.926886 and so on. All right, if I want to get my interquartile range, I need my Q3 and my Q1. So what we're going to do here, we're going to hit function, stat, and then we're going to hit quartile. Now, the interquartile range is a little bit different. So what we need to do after we hit quartile, we're going to hit the ABC button and click on the brackets that look like this. So when I hit the ABC button, I'm going to click on my brackets. I'm going to put the data set within the brackets. So I'm going to put 2, 5, 10, 8, 7, 9. Oops. All right, so I've got my entire data set separated by commas. If I'm looking for the Q1, I'm going to put a comma on the outside of the bracket, but inside the parentheses, and I'm going to put the number 1. That's going to give me my first quartile. So I know that my Q1 of this data set is 5. Now to get the Q3, I'm going to delete that 1 and I'm going to put 3. Now that gives me the Q3 of the data set, which is 9. So to calculate the IQR, I would do Q3 minus Q1. So 9 minus 5, which would give me 4. All right, so I want you to use the data set from example 1 to find the following measures of variability. I want you to find your range, and then use your Desmos app to find your standard deviation and your IQR. Do the same thing for example 7. I wish I could work out example 6 and example 7 with you, but I don't have the numbers from example 1 or 2 because I haven't done class yet today, filming this video before. So we'll have to, I want you to put your answers into the Edpuzzle, and I'll confirm that we all have the same answers for these two. All right, now for example 8, I want you to imagine that all of our names were actually twice as long as they actually are. We've already done these numbers, right? We did them before on example with the example 3, right? So I want you to go back to example 3 and find that data set where we imagine that all of our names were actually twice as long. Use that data set and find the range and the IQR and the standard deviation. All right. What did you notice about the range, the IQR, and the standard deviation when the data set was twice as long? All right, I hope that you noticed that everything else was twice as long. I could have multiplied the range by 2 and got the new range. I could have multiplied the standard deviation by 2 and got the new standard deviation. And I could have multiplied the IQR by 2 and got the new IQR. All right, next up, I want you to imagine that we all forgot to include the last 3 letters of our name. Do we need to collect the new data and calculate the mean and the median all over again? Well, let's try it. Let's use our data set from example 3 where we subtracted 3 from all of our names. I want you to take that data set and find the range, the IQR, and the standard deviation and compare it to the original range, IQR, and standard deviation. All right, what did you find out? Did it change or did it not change? All right, I hope you realize that this is a weird scenario. My range, my IQR, and my standard deviation all stayed the same, even though we added 3 letters to each of our names, right? So looking at this original data set where I showed you how to do the Desmos, and I calculated the standard deviation of this data set, and look, I added 1 to every single number. 2 became 3, 5 became 6, 10 became 11, 8 became 9, 7 became 8, and 9 became 10. So I just added 1 to every single one. My standard deviation is still the same. So we need to remember that when we're adding or subtracting, my measures of spread stay the same. They don't change. So I made this little graphic organizer here to help us. If we're transforming data sets, meaning we're multiplying or dividing every number in the data set by the same amount, or we're adding and subtracting every number in the data set by the same amount, what happens to our measures of spread and our measures of center? Well, I hope you found that every single one of them changes, except when we're adding or subtracting with measures of spread. And when I say changes, I mean you multiply or divide measures of center by that number. We add or subtract the measures of center by that number. So if everything in the data set is changed by multiplying by 3, Well, I'm going to multiply my measures of center by 3 as well, and I'm going to multiply my measures of spread by 3. Everything changes except for when we're adding or subtracting with our measures of spread. All right, so let's go ahead and try a practice AP problem here. So data on the number of text messages sent one weekend by junior and senior high school students in a large high school is summarized below. All right, so look, I have my minimum, I have my max, so I can automatically calculate my range. 152 minus 6, 146. All right, I've got my Q3 and my Q1, so I can calculate my IQR. 86 minus 15, and I get 71. All right, I've got my median, I've got my mean, and I've got my standard deviation. So before we get started, let's go ahead and I'm going to highlight my measures of center. So mean and median are measures of center. My standard deviation and my IQR are going to be measures of spread. So I'm going to highlight this over here as well so we know what goes with what. All right. An AP statistics student checking the calculations finds that the message count for all students was underreported by 5. When the numbers are corrected, what are the corrected IQR and standard deviation? All right, so what are we doing to every single piece in the data set? If everything was underreported by 5, how do I correct it? We're going to add 5 to every single number in the data set, right? So we're adding or subtracting. All right, it's asking us for the corrected IQR. Is IQR a measure of center or a measure of spread? And it's asking us for the corrected standard deviation. Is standard deviation a measure of center or a measure of spread? All right, so I'm adding 5, and I've got 2 measures of spread. So I'm in this box right here, right? Measure of spread, adding and subtracting. So it stays the same. So we can look, and I know that my IQR is not going to change. We calculated it to be 71, so it's got to be A or B. And then my standard deviation was 41.2. It doesn't change. So A is my correct answer here. All right. Here's another Barron's multiple choice practice problem. I just typed it in. I didn't pull it from the actual book, but this is from the Barron's book. So go ahead and take a minute and see if you can get this one. All right, suppose the average score on a national test is 500 with a standard deviation of 100. If each score is increased by 25, what are the new mean and standard deviation? All right, so first, is the mean a measure of center or a measure of spread? All right, I hope you said center. What about standard deviation? Is that a measure of center or a measure of spread? All right. And then if each score is increased by 25, so all I'm doing to every data set is adding 25. So let me go back to my chart. If I'm adding or subtracting, my measure of center changes and my measure of spread stays the same. So it looks like my spread will stay the same and my center will change. All right, so if my original mean was 500 and it changes, I should add 25 to that. So I'm going to eliminate A and B. C, D, or E has to be my correct answer of 525. My standard deviation was 100, and it's going to stay the same. So C is the correct answer here. All right, part 3, our last part, outliers and skewness. All right, so we've talked about identifying potential outliers, right? Now we're actually going to identify them based on our low outlier test and our high outlier test. All right, so I abbreviated hot and lot. That was Rakia Butler my first year that came up with hot and lot. It's easy to remember. So a low outlier test is going to be any value in the data set that is below the lot, And the high outlier test is going to be any value in the data set that's higher than the hot. All right, that should say hot. So many typos. All right, so looking at the lot, it's going to be your Q1 minus 1.5 times the IQR, and your hot is going to be Q3 plus 1.5 times the IQR. Remember, lot stands for low outlier test, hot stands for high outlier test. So it looks like the main thing that we need to know from the data set is what's the Q1 and the Q3. If I know my Q1 and my Q3, I can calculate my IQR. All right, so looking at this, I want you to take a second and use your Desmos app to find the first quartile and the second quartile for this data set. All right, I hope you got 1.5 for Q1 and 29 for Q3. So I put everything into Desmos by hitting function stat quartile. I put my data set in the brackets and I put comma 1 to get the Q1. Now to get my Q3, I'm just going to change that 1 to a 3. And that, oops. I'm sorry, I wrote it down wrong. 1.5 and 36, my bad. I don't know why I wrote that down wrong. Okay, 1.5 and 36. And that makes sense when we actually look at the data set. So these numbers are written out in order, and there's 12 altogether. So if I cut the data set in half, I have 6 in the first half and 6 in the second half. Since it's an even number, my Q1 is going to be right in the middle between the third and fourth data values. So in between 1 and 2 is 1.5. And my Q3 is going to be right in the middle between 32 and 40, which is going to be 36. All right, so go ahead and calculate the IQR. All right, so 36 minus 1.5 is going to give me 34.5. All right, now let's multiply 1.5 times the IQR, because that's part of our high outlier and low outlier test, is the Q1 minus 1.5 times the IQR. So 34.5 times 1.5 is going to give me 51.75. All right, so let's do our hot and our lot. Our lot is going to be Q1 1.5 minus 51.75. That's going to give me a negative number, so I automatically know I've got no low outliers, right? 1.5 minus 51.75. That's going to give me a negative 50.25. So I definitely don't have any values lower than that. I have no low outliers. All right. Let's try the high outlier test. That's going to give me my Q3, which is 36, plus 51.75. Remember, the 51.75 is 1.5 times my IQR. So 1.5 times 34.5. All right, so 36 plus 51.75 is going to give me 87.75. Do I have any pieces of data in my data set that are above 87.75? I do. 100. So yes, we have one high outlier at 100. All right. Skewness we've already talked about within the shape when we did our packet on shapes of distributions. This positive skew is another way of saying right skew. This negative skew is another way of saying left skew. Now we say positive skew because our numbers increase going this way, right? So these are higher numbers down on this end, so it's a positive skew. This would be a negative skew because there are lower numbers on the left side. All right, so this shows what happens to our measures of center whenever we have a right skew or a left skew. Remember we talked about how the mean is the most susceptible for the skew, so your mean is going to be the highest number out of all three. Your mode is always at the top of the peak, and I know we haven't really talked about mode before, but mode is the most occurring number. That's why it's the number at the very top of the peak. and then your median is going to be in between, right? In between the mean and the mode and the mean. If we have a symmetrical distribution, everything is the same value. If we have a perfectly symmetric distribution, then your mean, your median, and your mode are all going to be the same number, right here at the top of the peak. All right, if your distribution has a left skew, then your mean that's more susceptible for the skew is going to come this way. So your mean is going to be the lowest value. Your mode is now going to be the highest value, and your median is in between. So there have been practice AP questions that ask you to rank from lowest to highest the mean, median, and mode with different skews. So I would just remember that your mean is going to be the most susceptible. It's going to be skewed in that direction of the skew. So if you have a right skew, your mean is going to be the highest number. If you have a left skew, your mean is going to be the lowest number. All right. All right, so we have an outlier problem and then a multiple choice practice problem. So go ahead and pause the video and see if you can identify any outliers in the data set below. All right, here is what I got. So the Q1 is 7, the Q3 is 11. So your IQR is going to be 11 minus 7, which gives you 4. So here's the low outlier test and the high outlier test. I'm going to take Q1, which is 7, and subtract 1.5 times the IQR. I end up getting 1 for my low outlier test. For my high outlier test, I do Q3, which is 11, plus 1.5 times the IQR. So I get 17 as my high outlier test. So looking at the data set, it looks like I do have one value that's below 1, and that's 0. I don't have any values above 17, so this data set, this distribution, has one low outlier at 0 hours. Distribution has one low outlier at 0 hours. Okay, so tell me, what do you think will be larger, the mean or the median? Looking at this, if I have a low outlier, can you tell me which you think will be a larger number, the mean or the median? Remember, if I have a low outlier, it's skewing my mean down. So my mean is going to be less than my median. It's skewing my mean toward the outlier. So my mean is going to be the smaller number, my median is going to be the larger number. All right, go ahead and take a minute to do this next one. I hope you answered E. This was a difficult question. This was a practice AP question. So it's asking you about the outliers. So you know that you need to do your low outlier and high outlier test, right? So your low outlier test is Q1 minus 1.5 times the IQR, and the high outlier test is Q3 plus 1.5 times the IQR. The interquartile range is going to be 38 minus 25, and you get 13. So when you plug in all your numbers, you get 5.5 for the low outlier and 57.5 for the high outlier. All right, now looking at this, my sample is 55. So I have 55 pieces of data in my data set, but I don't see them, right? I'm only given the summary information, so I don't know what the data set actually looks like. I know that no values are below 10, so it looks like I can't have any low outliers. But my max is 60, and my high outlier test is 57.5, so I know that 60 is definitely an outlier. So I can eliminate A, B, and D, because that talks about the value of 10 being an outlier, and it's not. C and E talk about 60 being an outlier, but C says there can be no others, whereas E says there may be others at the high end of the data set. So since we can't see the underlying data, we don't know if there's any other pieces of data that are above 57.5. For example, we could have something in the data set that was 58. 58 would be bigger than our high outlier test, and it would be lower than the max, right? So it could be in the data set, and we just wouldn't know because we don't have that underlying data. So E is the more correct answer. 60 is definitely an outlier, and there may be other outliers in between the values of 57.5 and 60.